Hi Precalculus, this is question number 8 from chapter 5 review. So solve the following logarithmic equations. Okay, the first one is log base 2, 3x minus 2 equals 4. We're going to log loop it and get 2 to the 4. And we're going to add the 2 over. And we get 3x equals 18, so x equals 6. If we want to do a little check, you plug in 6, you get 3 times 6 is 18, minus 2 is 16. Log 16 base 2 means 2 raised to what power is 16, and that is indeed 4. So, looks like that worked out. Okay, log base 10, it's a common log. The implicit base is 10 of 100 to the x minus 4 equals 10 in part B. I could log loop it, and I'd get, not the only way to do it, you can express both sides with logarithm as well. Oh, you know what, maybe we'll do it this way, where we're going to fly that exponent and write as x minus 4 times log 100 equals 10. And so that log 100 is just 2 equals 10. So I get x minus 4 equals 5 if I divide by 2, and I add the 4 over, I get x equals 9. To check that one, if I plug in the 9, I get log 100 to the 9 minus 4, which is 5. So 100 to the 5th power means 100 times 100 times 100 times. So each of those pairs of zeros multiplied 5 times by itself is going to get you 10 zeros. And log of that number base 10 is 10. It's describing sort of the number of zeros. Alright, let's move over to this side, part C. And it's saying log base 8 of x minus log base 8 of x minus 3 equals 2. It's nice that both of the logs have a base of 8. So instead of taking a difference of logs, I can take the log of the quotient. Now I'm going to log loop, and I'm going to get x over x minus 3 equals 8 squared. I can cross multiply, and I'm going to, in the back of my mind, just pay attention to the fact that x cannot equal 3 in this case, right? Because we're multiplying both sides by 0 otherwise. And more importantly, also going up here, right? X has to be greater than 3 actually for it to have a positive value. So I could actually say x has to be greater than 3. But as we continue, let's see what we're going to get. X equals 64x minus 12, 1, 18, 19, 192, which means I get 63x equals positive 192, or x equals 192 divided by 63. We're going to go to our calculator here. 192 divided by 63. Well, pretty gnarly number. It did come out to be greater than 3, which is nice. To check this, I'm going to actually store this value to not lose too much accuracy. I'm going to store it as a, and then I'm going to say math log base 8 of a minus math log base 8 of a minus 3. And that should equal 2. Okay, so it does work. The numerical approximation here is 3.0448. Okay, continuing, let's see here, we get part D. 2 times log base 5 x minus 3 plus log base 5 of 2 equals log base 5 x squared minus 3x. Alright, so first I'm going to fly that exponent, the coefficient of the first term, express it as x minus 3 squared. And it's nice that again here also all the logs have a base of 5, and that'll be nice to combine and get rid of. So now we have a sum of 2 logs, so we're going to write it as a log of a product. Okay, and it's commutative, so I can switch that order. And now since we have log base 5 of both sides, we can drop the logs on both sides, which means if log of A equals log of B with the same base, then A has to equal B. And here I'm going to sort of FOIL it out with itself. And I get x squared minus 3x. This is a quadratic, so now when I distribute this, I'm also going to move things over to this side, all to the same side, and set it equal to 0. I'm going to get x squared minus 9x plus 18 equals 0. So factors of 18 that add up to negative 9 are x minus 3 and x minus 6, which means x is equal to 3 or 6. Now, already looking at our equation here, x cannot equal 3, because that would yield a log of 0, which is going to be undefined, right? 5 raised to no number is going to give you a 0. So 3 is out of the running. Now to check 6, let's see if we can plug 2 math log base 5 of 3, which is 6 minus 3, plus log base 5 of 2. And sometimes what I like to do is just subtract the other side and see if we get 0, instead of having to do 2 separate calculations. Log base 5 of 6 squared, 36, minus 6 times 3 minus 18, 18 should give us 0, okay? So the 6 does work out. Hope that helps.